Identifying the domain and range of a relation is important because that ties in directly to our definition of a function. A function is a relation that assigns each element in its domain. Again, that's our list of x values or our collection of all of our x values to exactly one element in the range, which again is that collection of all of the y values. So in order for a relation to be a function, every x value needs to be paired with one unique y value. We want to take this definition, for example 3, and look back at examples 1 and 2 and identify which of these relations are functions and which are not. In example 1, we have no repeated x values. In example 1 part A, we have no repeated x values. So yes, this is a function. In part B, we have a repeated x value, which is -6. But every time that -6 occurs, it's paired with exactly the same y value. So yes, part B is also a function. In part C, we have x equals 10 repeated. And when it's repeated, it's paired with different values. It's paired with a 4 and it's paired with a 9. That's what breaks our definition of a function, because we have one x value paired with more than one y value, paired with both y equals 4 and y equals 9. So that relation in part C would not be considered a function. In part D, we have x equals 4 and x equals 2 being repeated. When x equals 2 is repeated, it's paired with the same y variable each time, but 4 is paired with two different values. So since x equals 4 is paired with different y values, then that is not a function. In part E, we have repeated x values of -7 and -9. But each time that x value occurs, or I should say each time that value of x equals -7 occurs, it's paired with the same y coordinate. And each time x equals -9 occurs, it's paired with the same y coordinate. So even though we have x values being repeated, it's always paired with the same y value, a single and unique y value. So yes, that relation in part E is a function. Now we want to apply that same idea to example 2. In example 2, the first graph, there are no repeated x values, so that already gives it away that yes, this is a function. But for the second graph, we have a repeated x value, which is this value of x equals -8. At x equals -8, we have two different y coordinates because that point exists at two different places in space. We have -1 and -8. So since we have the same x value occurring paired with different y values, then no, this relation is not a function. Now we want to expand this idea. In the previous examples, 1 and 2, we were dealing with finite lists of points. We had just a collection of points, but in example 4, we're dealing with curves that continue on forever. So we want to ask the same question or investigate the same definition to determine whether or not these graphs represent functions. So looking at the first graph, we're going to apply what we refer to as the vertical line test. The vertical line test tells us that we draw a vertical line passing through that curve, and we look to see if it intersects the curve in more than one place. And for this first graph, there's no vertical line that we can draw that would intersect the graph more than once. Doesn't matter where we plot those, we would only ever hit the graph once. So this first graph is a function because every x value is paired with a unique y value. Versus the second graph, there are lots of places we could draw a vertical line where we would intersect the curve in more than one location. So that means we have the same x value paired with more than one y value. So the second curve is not a function.